This is FRQ 2026 question. Let me read the question for you. Water exits the nozzle of fountain at an angle theta naught above the horizontal. At time t is equal to 0, a droplet of water exits the nozzle and follows the path shown in figure 1. The droplet reaches maximum height h1 above the nozzle. At t is equal to tf, droplet returns to same horizontal level at which droplet exited the nozzle. So these two levels are same. And then we have to draw horizontal component of velocity and vertical component of velocity with time. Okay. So first see here, when that water droplets has been ejected, I can say only gravitational force mg is acting on it. So of course, the path followed by water droplets will be parabolic path. You have to mention it, and only gravitational forces acting on it. So we do know that direction of acceleration and direction of force is same. So if gravitational force is acting in downward direction, then acceleration of water droplet should also be in downward direction. So acceleration will be equal to g. In which direction? It should be in y direction. And at the same time, you have to mention sign convention as well. Since gravitational force is acting in downward direction, acceleration is in downward direction, I am writing negative here. So acceleration in y direction is minus g, and there is no acceleration in x direction. So if there is no acceleration in x direction, velocity in x direction should be constant. So the particle or that water droplet was ejected with velocity v naught. So I'm resolving this velocity into two components. This is horizontal component and this is vertical component. V naught cos theta naught and V naught sin theta naught is vertical component. This component will remain same because acceleration in x direction is 0. So I know this component V naught cos theta naught, this will remain same. So horizontal velocity component Vx will always be V naught cos theta naught. It will not change. Right. Now, what is initial velocity in y direction? It is nothing but V naught sin theta naught. Right. And we know this formula Vy is equal to Viy plus Ay into t. But at the same time, to earn more points, you should mention that this can only be applied when acceleration is constant. And here acceleration is constant because g is constant. Or gravitational field can be assumed, gravitational force can be assumed to be constant. So I'm applying this formula. Final velocity in y direction Vy is equal to initial velocity in y direction V naught sin theta naught minus acceleration in y direction with proper sign, that is minus dt. So this is velocity in y direction, which should be decreasing with time. And if I write t is equal to 0 initial, then initial velocity was v naught sin theta naught. So at t is equal to 0, initial velocity was v naught sin theta naught. And when time increases, this velocity in y direction will decrease. And let me mention this point. This is a special point. Why? Because at this point, final velocity in y direction is 0. And after that, velocity in y direction becomes negative. So if particle is moving like this is velocity in y direction, which is negative. And if particle was moving like this, then this is velocity in y direction, which was positive. So here velocity in y direction was positive. Here velocity in y direction was negative, and at this point, velocity in y direction is 0. So first positive, then 0, then negative. So graph will be like this, and this will be minus v naught sine of theta naught. Why linear? Because the function itself says that is it is linear function of time. So I have plotted it. And why velocity in y direction will be minus v naught sine theta naught, then you can say that should be as per energy conservation. So velocity in this direction will be equal to v naught cos theta naught, and velocity in this direction will be equal to v naught sine theta naught. So initial kinetic energy will be equal to final kinetic energy because they are at same horizontal level. So we have completed this part, and you have to mention all these to 10 points. Now let us see another part. It is second one. Derive an expression for speed of water exiting the nozzle. Okay, so we have to find speed, that is V naught of that particle, and we have to express our final answer in terms of theta naught h1. And what was h1? H1 was maximum height achieved by particle. Right, now see here. Of course, I can say that final velocity in y direction square will be equal to the square of initial velocity in y direction plus twice ay into displacement in y direction. So this is initial point and this is final point. So initial and final, if you see what is vertical displacement between them, so this is h1, and you have to mention that vertical displacement is positive and it is plus h1. Why? Because this is initial horizontal level and this is final horizontal level, and this is displacement in upward direction, so this is plus h1. And another important point which has to be mentioned, this velocity component will not change, it will remain constant because there is no horizontal force, but this component will decrease with time initially because gravitational force is acting in downward direction. So if gravitational force is acting in downward direction, this velocity should decrease, and you can see at highest point velocity in y direction will be 0. So there will be no velocity in y direction, but velocity in x direction will remain same, that is v naught cos theta naught. So what is final velocity in y direction? That is 0. What is initial velocity in y direction? It is v naught sine theta naught square. Acceleration I have already told you, it should be minus g, and displacement is positive, that is plus h1. So if you solve this, you will get v naught is equal to under root of twice gh1 upon sine theta naught. But at the same time, you do have to mention the sign convention, and you have to mention that at highest point, velocity is not 0, but velocity in y direction is 0 because velocity in x direction will always be constant, and that will be equal to v naught cos theta naught. Okay, so let me read the third part. The nozzle has circular cross section with radius r naught. Derive an expression for volume flow rate of water exiting the nozzle. Express your final answer in terms of theta naught, h1 r naught, and physical constant as appropriate. For incompressible liquid, we know that volume flow rate is given by A1 into V1. And what is A1? A1 is area. So if you see this, let this be the pipe through which water droplets are ejected with velocity v naught. So this is area pi r naught square. R naught is radius of this nozzle. So r is equal to area will be equal to pi r naught square, and velocity we have already calculated. I have just placed it here. So this is expression for r. Now let us see part B. The fountain nozzle is replaced by new nozzle with radius smaller than r naught. The water exits the nozzle at same angle theta naught above the horizontal. So they are saying that theta naught is not changing. However, radius of that nozzle has been reduced to r naught. So now we have to compare maximum height, which is h2 in this case, with the maximum height of previous case, which was h1. So once again, with the formula approach, it is very easy. I can say that if R is maintained constant because they have said that volume flow rate of water is constant, and if volume flow rate of water is constant, this R is constant. So if this R is constant and area is decreased, then definitely velocity has to be increased. So if velocity is increasing, you see here, if you are increasing velocity, if you are increasing velocity, so if V naught is increased, then velocity in y direction, that is V naught sine theta, will also increase. So if V naught sine theta will increase, then as per this formula, if V naught sine theta is increased, then height achieved will be more. In part B, it is given that the fountain nozzle is replaced by new nozzle with radius smaller than R naught. So the radius of this nozzle R naught is decreased. Water exits the new nozzle at same angle theta naught above the horizontal. That means this angle theta naught has been kept constant. Volume flow rate of water exiting the new nozzle is equal to volume flow rate of water exiting the original nozzle. That means volume flow rate is also constant. This area is pi r square. So radius has been decreased, but this r is constant. So this is constant. R volume flow rate is constant, and this area has been decreased. It implies that velocity has to be increased. So this velocity has been increased. And if velocity V naught is increased, I do have velocity in y direction, which is given by V naught sine theta naught. So velocity in this direction, that is in vertical direction, has been increased. So obviously, if velocity in vertical direction is increased, the height reached by water droplets will be more when compared with previous height. So I can say that new height, maximum height h2 will be greater than h1.